Components of a force. We often have to resolve forces to find the resultant force. If the resultant force is 0, then the object is said to be in equilibrium. When we resolve forces, we make two equations, one for the forces parallel to the surface, in this case the horizontal, and another for the forces perpendicular to the surface, in this case the vertical forces. So in this example, the full force of 5 acts against the full force of 3, giving a resultant force of 2 newtons to the right, and the object is in equilibrium as it's not going into the surface or floating above it, so the weight force of 2 newtons is counteracted by a 2 Newton reaction force. However, the forces are not always parallel or perpendicular. Sometimes they are at an angle to the surface. So in this case, the angle is 30 degrees and the force is 5 newtons. Thankfully, we can use right angle triangle trigonometry to find the components in the parallel direction and the perpendicular direction. And then we can use the parallel component in our parallel equation and the perpendicular component in our perpendicular equation. So I'm going to just mark on with a dashed line the parallel component. This force is going to the right and up, so I'll mark an arrow to the right, and then with the perpendicular component I'll mark an arrow going upwards. And now I can just use right angle triangle trigonometry to write an expression for each side in terms of the angle and the force. So just using cos of 30 equals adjacent over hypotenuse. The hypotenuse is 5. I can rearrange that to give an expression for the adjacent, 5 cos 30, and I can write that 5 cos 30 on there. Similarly, I can do the same for the opposite side. Sine of 30 is opposite over hypotenuse, so the opposite is 5 sine 30, and I can write that on the diagram. And if these values simplify, if they have exact values, they can be simplified to make it easier on the diagram. And in general, this can be done for any force at any angle. So at the angle here is theta. The parallel force will be the force. Now here we had the force of 5, so here the force is F, and the angle is theta, so F cos theta, and the perpendicular force is F sine theta. Now, in my video, how does increasing the angle affect the force, I'll help you understand why sine and cosine affect the components of the forces in the two directions. Just click the link below or watch the full playlist for an understanding of forces, including surfaces such as slopes and ladders.